Hello, my name is Darren Holmes, and today I want to show you how to cut out and bend the new chassis for our 2020 SumoBot version 2.0. This is the prototype for our new SumoBot. You can see we're no longer using a printed circuit board, but we're going to use a piece of perf board to build our SumoBot. We're going to be using the Pololu P-Star 45K50 module as our processor, and we're going to mount our gear set and wheels directly to the piece of perf board. We're just going to offset it by putting in some spacers so that the wheels don't rub against our piece of board. Our new design has our perf board seated within the chassis. We also have some tabs at the lower end here that we're using smaller pieces of perf board to mount the lower sensors so that we can maintain an equal distance from the surface. So one other thing that we have is the battery pack, and instead of using 9-volt batteries, we're going to use 4 AA batteries, and the battery pack can be mounted with double-sided tape to the top of our chassis. And this will provide us with a little more weight and give us a little better traction in the ring. So today I want to show you how to cut out and bend our aluminum chassis for our 2020 version of the SumoBot. So this is our drawing for the SumoBot chassis, and I'll put a copy of it in PDF form in the notes below this video. So you can see that our chassis has to be approximately 10 centimeters. So all these dimensions are in millimeters. So 100 millimeters is 10 centimeters by about 18.5 centimeters. So the first thing I need to do is take my piece of aluminum and cut it out to those dimensions. So this is the aluminum I get brought in. It's approximately 4 inches by 8 inches, and we need it to fit in a SumoBot box. So this would be typical of the type of box you would see at a competition that your SumoBot has to fit in for the 10 centimeter class. So right now my aluminum's too big to fit in there. So I'm going to show you how to use the shear to trim off a piece of aluminum so that it will fit in the box. So the aluminum's too wide to fit in the box, so I'm just going to use the box as a reference here and just put a little mark on the side there where I need it to go into the box. And then I'll turn the aluminum around and do the same thing on this side. So I need it to fit in the box. So I'll just use a ruler and a marker to run a line down there. So make sure you double check this with a ruler, and you can see the 10 centimeter mark is just inside the line. So when we trim this, we want to cut the line right off of it. So this is our small shear. As you can see, there's a handle on it, and we use it to bring down the cutting edge. So when you look at our shear, you can see that along here is the cutting edge. Don't put your hands under it. This is a smaller shear that we use for trimming printed circuit boards. It's not large enough to trim aluminum, so please do not use it for trimming aluminum. So I just want to show you what our shear looks like. As you can see, there's a big handle on here that we use to pull down and actually cut our aluminum. So what we're going to do is take our piece of aluminum and slide it into the shear, and we need to line it up with the cutting edge. To do that, we have to look down into the machine and see where that line is along the cutting edge. So looking down inside our shear, you can see that we have a series of little fingers here, and just between the fingers you can see the edge where we're going to make the cut. So what we need to do is to slide our aluminum into the shear, and as it goes into the shear, we should be able to see the edge coming out the other side. So we need to line up that black line that we made with our marker to just the other side of those fingers. Now I just want to remind everybody that when you're bringing down that handle, make sure you hold on to your aluminum tightly, because as the shear comes down, it has a tendency to pull your work into it. So make sure that you do hold on to your aluminum very tightly. Now you want to try and get it as straight as possible, and then pull down the handle of the shear and it will cut off that edge for you. So out of the back end of the shear, we'll drop the piece that you've just cut off. So make sure that you do clean up back here and throw that piece in the garbage. So if you've cut your aluminum to the right size, it should now fit inside our box. If it's still a little bit tight, I'm going to show you how to file down the edge of the aluminum. We're going to need to do that anyway because the edges are quite sharp after we've cut it, so be careful running your fingers along it because you could cut them. So the next thing we need to do is cut our piece of aluminum to the correct length. You can see we're going to cut it to about 185 millimeters. So that's 18.5 centimeters. It doesn't matter if it's longer than that, it'll just hang down a little further at the back or move in a little bit from the front, so don't worry about getting it to the exact dimensions. So using my ruler, I'm going to make a small mark at 185 millimeters, and down at the other side I'm going to mark it off at 185 millimeters, and I'm just going to put a line down there. So the next step is to file the edges. So what we're going to do is put it into one of these vices here. Now before you do that, I just want to point out to you that the grips on the vise, we're going to leave some dents and some impressions in your piece of aluminum. So before you put your aluminum in there, I recommend you use a couple pieces of cardboard and just put a piece on either side of your aluminum. So placing a piece of cardboard on either side of your aluminum, place it into the vise, and remember to keep your fingers out of the vise. You want to place it fairly low down so that when you're running a file over it, it doesn't wobble all over the place. So then close up the vise and make sure you have it tight so that it doesn't slide out. So the next tool you're going to need is a file, and you need a fairly fine file, not one that's made for wood, but one that's made for metal. And what we're going to do is we want to hold it with two hands, and we want to keep the file level as we push it across our piece of aluminum. Now you'll notice there's some grains in our file. So we want to be able to push the file so that the grain cuts across our aluminum. So holding the file level, we're going to push it across our aluminum. And we want to keep the file level. And you want to make sure that you don't push harder on the ends or else you'll curve your ends round. So you want to keep it nice and flat and just push it across the aluminum. So once you've done that across the top of the aluminum, the edges are going to be a little bit sharp. So be careful with your finger running it along an edge because it will cut your finger. So what we do is we break the edge by putting the file on an angle and just going across it. So all the way along the edge, trying to get rid of that little ridge that could hurt our fingers. So we want to do that on all four sides of our aluminum. So once you've finished filing all the edges of your aluminum, we would typically try and make sure that all the corners are actually square. So to save you time, I'm going to show you another technique. What we're going to do is find the center line of our aluminum, and then everything will automatically square up from that. So taking your ruler, we know that the aluminum is going to be approximately 10 centimeters wide. So at the 5 centimeter mark, that's going to be our center line. Now what we want to do is try and get the aluminum between the 0 point and the 10 centimeter mark. Now typically on most rulers, the end is not truly 0. So some of these divisions might be a little larger than others. So when we're measuring something, we usually start at the first division. So we're going to go between the 1st and the 11th. So the midpoint would be at 6. So at 6, I'm going to scribe a little line. So that's my midpoint of this end of my board. Now it doesn't matter if the 1 is a little further over and the 11 is a little further over outside the boundaries, meaning that your aluminum is smaller than anticipated. All we're interested in is the exact center point. So turning my aluminum around to the other end, we're going to mark its center point. So it's going to be between 1 and 11. So I mark a little line at the 6. Now the next thing I'm going to do is take my ruler and go between those two lines and make sure that you do get this exact, because it is the center line. We're going to scribe a line right down the center. Now you're going to have to push fairly hard because we want this line to show up. So now you can see I have a center line directly down the center of my piece of aluminum, and it doesn't matter if one side is a little larger than the other. It doesn't need to be squared up because I've got an exact center line. So the next thing I'm going to do is cut out my layout and glue it to my piece of aluminum. So all we have to do here is take a pair of scissors and just cut out the layout. You don't need to be neat, you just have to cut to the edges. So this is my layout cut out. Now you'll notice that there is a center line right down the center of my layout. So the next thing I'm going to do is cut little triangles at either end. So you don't have to be exact. So I need a little triangle at this end. So now when I place my paper layout on top of my piece of aluminum, all I need to do is get the center line going exactly where I scribed the center line on the aluminum. And then I can slide my piece of paper back and forth. So now what I'm going to do is I'm going to glue my paper to the aluminum. That way I've got all the lines put on my piece of aluminum rather than copying them over one at a time. So to glue it down, I'm just going to use a standard Elmer's type craft glue stick. And you can see this is the purple color. So all you need to do is put a fair amount of glue onto the paper. Make sure you get it all the way across the paper, because as you're bending this, it's going to have a tendency to pull off of the aluminum. So you want to get a fair amount of glue down there and get it right to the edges, or else it'll peel off as you're working with it. Remember, if you're using my glue stick, to retract it a bit and put the cover back on so it doesn't dry out for the next student. And then very carefully make sure that you do get those center lines lined up. So we want it both with the paper and the aluminum. Spacing on the ends is not critical, but getting that center line on the center line is critical. Okay, it doesn't need to be neat because once we bend it, we're going to take this paper off. So there we are. We've transferred our layout to our piece of aluminum, and you can see that the center line does line up with the line I've scribed in here. So whenever I do my bends, they're all going to be perfectly square without actually having to square up my aluminum first. So looking at my piece of aluminum, you can see the shaded areas need to be cut out. So we're going to use a punch press to cut those out. We're just going to nibble away pieces until we get close to that line, and then we'll file it out. Now before we do that, we have some drilling holes to be done. And what we're going to do is we're going to tap these holes. So we have to use the appropriate size drill bit for the tap that we're going to be using. The bolts that we're putting in here are number 4 and they're 40 threads per inch. So it's a 440 bolt that we're putting in here to hold our circuit boards in place. Now one of the things that's going to happen is as we bend this, we're not going to know exactly what the length is going to be between this hole and this hole. So when you look at my diagram, you can see for the perf board we're using, it needs to be 70 millimeters between those two holes. So right now, it's a lot larger distance, and it won't get close to 70 until after we've bent our chassis. So one of the things that we're going to do is we can drill the front hole here for our lower sensors, and this hole here for our piece of perf board, and later on when we finally do assembly, we'll drill the 2 back holes later. But it's just easier to drill the front holes. So here's the front holes. So it's just easier to drill those while the aluminum's flat, and then we'll struggle to drill these 2 once the aluminum has been bent to shape. Okay, so this is a number 440 nut and bolt. So this is the nut on the bottom and the bolt on the top. So to save money, typically what we do is we would actually thread the hole so that we don't need the nut. So that would save us a few cents per nut on the manufacturing of a product. So we thought it would be kind of interesting for you to actually thread these holes yourself. So this is a tap and drill chart that I just grabbed off the internet. This is for standard sizes, so this is not metric. There'd be a separate sheet for metric. So this is your screw size, so we're going to be using a number 4, which has a diameter of 0.112 inches. Okay, we're going to be using 40 threads per inch. You can see there's a finer one at 48 threads per inch, but we're going to use 40 threads per inch. So they're saying the tap drill size, and this is for aluminum, is going to be a drill bit size of number 43. So 43 is larger than 3/64, and it's smaller than the next one they show me down here is 7/32. So it's between those sizes. So you'd actually purchase it as a number 43 drill bit. So this is our number 43 drill bit. So you can see it's a little larger than the drill bits we've been using so far. And this is the actual part that's going to be cutting the threads in our aluminum. So you can see we have a little tapered end here, so that goes into the hole in the aluminum, and then the threads on here actually cut the threads in the hole. So this is called a tap handle. So this device here that cuts the threads goes into the tap handle and gets tightened up. But before we can cut our threads, we actually have to drill our holes. Now there's one last thing I want to show you on this chart here, and that's these columns over here on the right hand side. So they're telling you what the clearance drill bit will be. So we're going to be using a number 440, and a close fit is 0.116 inches. A free fit is 0.129 inches. So the closest drill bit we have is a 0.125, which is a 1/8 inch drill bit. So you can see this is our drill gauge, and you can see we have a hole here for 1/8 inch, which is 0.125 inches. So when you take a little bolt that we're going to be using on our chassis and we place it in the hole for the 1/8, you can see it's a fairly free fit. So this is not the size hole we want to use if we're going to tap the hole, but it is the size we use if we want the bolt to slide through the hole. So this is a 1/8 inch drill bit, and you can see that it fits in the hole for the 1/8, and it fits fairly tight. Now the other drill bit that we have is the number 43. So this is the number 43, and when you place it in the 1/8 inch hole, you can see it's fairly loose. In fact, you can see it fits in the 7/64 hole, and it fits in the 3/32 hole. So we're going to be using both drill bits in the back room, so make sure you can tell the difference between the two. If you accidentally drill a hole with a 1/8 inch bit, you're not going to be able to tap it, so you're not going to have the threads necessary for the screw to actually screw into your piece of aluminum. So do not mix these two drill bits up, and if you have a problem telling them apart, you can actually use this drill gauge. So the 1/8 inch drill bit fits in the 1/8 inch hole. It will not fit in the 3/32 inch hole. The number 43 inch drill bit will fit in the 3/32 inch hole. So before you drill your hole, make sure you use your drill gauge to check and make sure you've got the right drill bit in the drill press before you drill. So to drill our holes, we're going to use a large drill press in our back room. Using the Dremel drills, they don't have enough torque to go through metals. Even though aluminum is a soft metal, we do have to use a fairly heavy-duty drill press. So to adjust our height of our plate here, we have a little lock handle at the back here. So turn it counterclockwise to unlock it. And then on the other side of the table, we have a little crank handle. So if you turn it clockwise, it will move the plate up. And if you turn it counterclockwise, it will lower the table. It's very important that when it is the right height, that you actually lock it back into place. And just to add one more thing, the center hole on the table needs to line up with the center of the drill press. Because when we put our drill bit into the chuck here and we lower it down, the drill bit is going to go through the aluminum and into the hole rather than trying to drill through our table. So the next thing we need to do is put the drill bit into our chuck, and you can see it has some little fingers here, so you can rotate it manually and see that it has 3 fingers in there that need to center the drill bit right in the center. So this is called a keyless chuck. So if you hold the 2 parts of the chuck, you can actually turn it, and that's with the fingers together, and you can see the drill bit can't get into the center. So if you turn it the other way, it should open up those fingers and you should be able to get the drill bit right into the center. So how far into the chuck should the drill bit go? Well, we want the fingers to make contact with the shaft, not into the part that actually has these cuts in them, right? Because the cuts go through the material, and as it's cutting into the material, it goes up the shaft and comes out. So we want the fingers to make contact with the shaft that doesn't have any cuts in it. So slide it into the center, and then we're going to slowly tighten it up. So you can see that we have to turn it counterclockwise for it to tighten up. Now once you've got the drill bit in and the fingers are tightening up against it, what you can do is hold the top portion, and you can see it's got these little gnarls in it so that you can grip it, and then grip the lower piece and just turn them. So the top one is going to be turned clockwise, the lower portion is turned counterclockwise, and that will grip your drill bit so it won't slide out. So over on the left side of the drill press, we have the on-off switch. Please make sure that you are wearing your safety glasses, that they're not on the top of your head. They will not protect your eyes up there. So make sure you always have your safety glasses on before you drill anything. So to turn this particular drill press on, move the switch towards the front. To turn it off, move the switch towards the back. Now on the right hand side, we have all these levers that we use to lower the drill bit into our material. So all you have to do is grab one of the handles and pull it towards you. And you can see the drill bit moves down towards your material that you're going to drill through. And as it goes through the material, it's going to go through the hole in the table. Now typically what we do is we don't drill directly on the table. We use a block of wood and then put our material on the block of wood and then drill through our material. So to drill these holes, what we need to do is actually lower the drill bit and see if it gets close to that little circle where we want the hole to be. So you might have to move it around on the table a little bit before you actually do the drilling. So I'm going to show you how to drill the first hole now. It's going to be a little noisy because I'm going to turn the drill press on and then drill the hole. So you can see I put a little bit of pressure onto the drill bit. I didn't bring it down quickly. I went slowly and just applying light pressure and let the drill bit do the cutting. So you can see once it went through, it kind of flexed back up again and pieces of material came out that we can sweep up and put into the garbage. So once you've drilled these 4 holes, there's going to be some fairly sharp burrs on these. So you don't want to cut your fingers on them. So I'm going to show you how to get rid of those right now. What you're going to do is you're going to use a larger diameter drill bit. And all you do is put it over the hole that you've drilled where those little sharp pieces are. And just pushing down and twisting, it will actually cut off those sharp burrs for you. Now you're not trying to drill a new hole. You're just trying to get rid of those sharp edges that are on there. So a few twists should get rid of them. So you need to do that for each of the remaining 3 holes. So once you've got the sharp edges off of your 4 holes, you're now set to go over to the punch and cut out the pieces that we do not need on our chassis. So the next piece of equipment I want to show you is our punch press. You can see there's a handle on it that actually brings it down to punch the hole into your piece of aluminum. We have a stripper plate on here, so your piece of aluminum needs to slide onto the table and underneath this stripper plate. So this is our piece of aluminum, and what I'm going to do is actually punch out these pieces here, this piece in the center, this piece on the other side, and then I'm going to come up here and punch out this little window, and then I'll punch out this side followed by the other side. So I just want to show you how I get started with that. We're going to use a technique called nibbling, so we just cut out a little piece at a time. We don't try and cut out the whole thing. So what we do is we slide it underneath. So this would be a stripper plate, this would be the table, so we just slide it between the two so that when the punch comes down and actually breaks off the piece of aluminum, when it comes back out it's going to be stuck, so it can't lift the aluminum back up. So just start at a little corner there just to get the feel of punching out a piece of aluminum. So I'm just going to cut off a little corner piece. So you can see I've cut out a little corner, but I need to take the whole thing out. So now I'm going to nibble away and slowly try and get close to this line without going right through the line, okay? So you can see on this one, I wasn't quite close enough, so I'm going to go put it back in and try and punch a little bit more off. So now you can see I'm a lot closer to that line, so now I'm going to come along and take some more off. Right, so now you can see I'm getting close to that line, but I wasn't quite close enough. So sometimes it takes a few attempts to try and get as close as possible. Remember to take your time and just take off a little bit at a time. We're going to be left with some rough edges that we're going to need to file off later. So I'm going to go ahead and nibble out the rest of this aluminum. So once you're finished nibbling it out, you can see that the edge is going to be fairly sharp, so you're going to need to file that down using the filing techniques that I showed you previously. So once you're done, finished punching out your piece of aluminum, the pieces that you've punched out are going to drop below. You need to use your dustpan and your broom, sweep those up. Sweep up any that have dropped on the floor and dispose of them in the garbage bin. So once you're done filing all the rough edges off of it and tried to smooth it out the best you can, just go over it with a piece of emery cloth. Emery cloth is kind of like a fine sandpaper with a cloth backing, so it makes it a lot tougher when you're trying to sand down a little bit of aluminum like this. So just go over those edges just to make sure that there's nothing sharp left there, so that we don't cut ourselves when we're trying to assemble our SumoBot. So once you have your piece of aluminum cut out, it's kind of important we have the paper left on here because that's going to show us our bend line. So this is our 90 degrees back here, and then we have our top roof line across here, and then our bottom scoop line across here. So what we need to do now is to bend our chassis into this particular shape, and to do that we use a tool, and it's called a brake. So this is our brake in the back room here. You'll notice it has these kind of fingers that come down and a table across here. So this is where we place our aluminum, between the table and these fingers. Once we have our aluminum placed in there, we actually lock it into place. So once it's locked into place, we can bring this handle up and it makes a crease in the aluminum right along the edge. So I'm going to show you how to position your aluminum in our brake. Okay, so on the layout that I gave you, you can see that we have the bent chassis view. So the back edge is really easy to do. That's going to be 90 degrees. The tabs, which we're going to bend later, they have to be at 90 degrees to the back end here. So when we take a look at the front end, you can see we have the front edge here that's 116 degrees, and a complete circle is 360, so a straight line is 180, so we have 64 degrees in this bend right here. So this bend we're going to do first. We're going to worry about the front tabs after we've done our major bends. So we're going to do this front bend first. So we need to get that to approximately 64 degrees. Then we'll do this front edge bend, and then we'll do the back end bend at 90 degrees. And it's better to underbend, because then you can go back and bend it a little bit more. If you overbend it, it's hard to unbend aluminum. So I'm going to show you this on our brake now. So we're going to place our aluminum in, and we have a bend line right across here. So we're going to try and get it in and lower those fingers down. And what we want to do is to see the line so that we can kind of square it up. Now we're not going to get it 100% squared up, but we're trying to see that we have the same amount of space on either side here, and we want to get it right onto that first bend line, but we want the line to be visible. So it's going to take you a few goes. So once you're happy with it, make sure that you do lock these into place. So then we're going to do our first bend. So we're going to lift it up, and you can see it actually bends it right along that crease line there. Now the first bend is a pretty major bend, so I'm going to start by moving it up and having you look at what about 90 degrees looks like. So I've bent my front edge to 90 degrees, so unclamp it and take it out, and you can see what 90 degrees looks like. So when you bring it in and line it up with the paper, you can see we have a lot further to bend. So I'm going to put it back into our brake and bend it over a little bit further. So once again, I'm going to close it up a little bit, and I'm going to slide my work back in, and make sure that you push it as far forward as you can so that it gets into the same crease line. So then I'm going to bring up the handles and bend it a little bit further over and try and eyeball the angle. And now I'm going to unclamp it and check it against my page again. So lining it back up on my page, you can see I've gotten fairly close. Do not worry if it takes you 2 or 3 attempts to get it right on. So now I'm going to put my aluminum in and make the next bend. So this time I'm going to put my aluminum in back end first, and I'm going to try and find that line that's the roof line. So I'm going to bring those fingers back down again and try and line up my roof line. And then lock it into place. So it's very important you get these 2 lines lined up, or else your chassis will be bent on an angle. So what we're going to do is we're going to bring the handles up, and you can see it bends our aluminum. And what we want to do is get this flat to be parallel with the bottom plate. That way we know we have the correct bend. So when you think it's just about level with the bottom plate, that should be the correct bend angle for you. So looking at our chassis and our layout, you can see that our bottom edge is indeed parallel with our roof line, and our roof line gives us the correct angle with the front edge of our chassis. It may take you a couple goes to get it, but once you've got that completed, we can now do the final 90-degree bend on the back end. So to do that final bend, we are putting the aluminum in from the back end, and we're trying to line up that roof line at the back end. So clamp it back down, and once again, make sure that you do get that bend line exactly level against those fingers, or else your chassis will be bent on a slight angle. So once you've got that back edge lined up, you can do the final bend, eyeballing it at approximately 90 degrees. And then we're going to do one final check, making sure that our aluminum chassis does actually line up with the diagram that I gave you. Now, before I show you how to bend the last of the tabs for mounting those pieces of perf board, we have to do one final check. And the final check is to make sure that the aluminum chassis that you've just bent still fits into the box. So the next thing we need to do is to bend these mounting tabs for the perf board. So to do that, I'm just going to take a pair of line pliers, and we just kind of line it up and do a kind of a best guess. So once you're happy with that, you can just twist your wrist and actually bend the aluminum manually. And we're trying not to bend it too much. That looks like it's a little bit too much. So you can put the pliers back on and unbend it a little bit. So we're trying to get it level with the roof line and level across the entire chassis of our aluminum SumoBot. So we're going to try and line up the next one. And then bend it over. So we're trying to get these two to be level, so it looks like it needs just a little more bend. So once you're done bending your tabs, you can try placing your perf board in there to make sure that it does sit flat. So make sure that you check all 4 tabs and make sure your board isn't rocking on the tabs. So the last 2 bends I need to make are for this little piece of perf board for the lower sensors. So I'll show you how that's done now. So we're going to start the bend with these line pliers. So just try and line it up as best as you can, and then just kind of bend it over. Now you're not going to be able to bend it all the way because the front of the chassis is going to stop you. So what we're going to do next is use a pair of needle nose pliers. So we've already made that crease there, so it should be fairly easy just to put the needle nose in and finish that bend. So we're trying to get the bend to go 90 degrees to the bottom line, so it needs to go a little bit further. So that looks like it's about 90 degrees. And then the other bend is covered up. So we know that it's going to be approximately 5 millimeters up. So just kind of eyeball it. And then make your bend with your needle nose pliers. Now you can see it's not going to be exact. So we're trying to get this flat with the bottom edge here. So providing you've got approximately a 1/4 inch there for the light to reflect off the ground and into the sensor, you should be okay. So we're going to do the second bend. We're going to start it off with the line pliers. Bend it as far as we can, and then finish that one off with the needle nose pliers. So now that we have the two lower tabs bent for that piece of perf board for the lower sensors, I'm now going to go and show you how to tap those holes that we drilled earlier. So earlier I drilled the front holes with the number 43 drill bit, and if you take your number 440 screw, you'll notice it will not fit through the hole. So the next thing we're going to do is use our tap, and it's got some threads on it, so we're actually going to put the tap in that number 43 hole that we drilled earlier, and then we turn our tap slowly to cut the threads in the aluminum. Now to do that, we're going to use a tap handle. So your tap slides into the tap handle, and then we have to tighten it up. Okay, so we can now use our tap to cut the threads in that piece of aluminum. Now before we do that, we want to use a lubricant. I'm just going to use a little drop of WD-40. So I'm just going to squirt it on my aluminum. Okay, we don't need a lot on there. So make sure that you hold your tap perpendicular to the hole. So we want to cut the threads directly straight down. So as you go further down, you'll find it easier to turn, and it should be fairly easy to take it out by turning it counterclockwise. Make sure that you do support the tap and the tap handle as you're taking it out, because you do not want to damage the threads that you've just cut. You should now be able to take your bolt. Remember, this is a number 440, and you should be able to twist it, and it should be able to screw directly into that hole that we've just tapped. So you need to mount the two lower perf boards first, and then you mount the upper perf board last. So I just want to remind everybody that we drilled and tapped the front holes, but we have not done the back holes. We were waiting to see where our chassis ended up being bent, what angles we've got in it. So now we can see, after mounting our perf board, where those two remaining back holes will be. So I'm going to leave you to drill those out and tap them on your own. So I just want to thank you for watching the 2020 SumoBot aluminum chassis build, version 2.0. Please don't forget to subscribe to see all my latest videos as they become available.